All right, this begins our lectures on Chapter 8. This is our first one in Section 8.2. We're going to be talking about factoring a GCF and factoring by grouping. Now, the first thing that we want to do is we want to discuss what does factoring mean. So factoring is the opposite of what we did in the last chapter. In Chapter 7, we learned to multiply polynomials out to get a sum of terms. But now in Chapter 8, we want to undo that process. We want to get a product of polynomials that is equivalent to a sum of terms. So the first step in factoring is always to look for a GCF, a greatest common factor, which is the largest number or number/variables that two or more numbers have in common. They're divisible by. So finding a numeric GCF, let's just very quickly review that process. In finding a numeric GCF, remember that we are going to find all the factors of a number. Geez, I'm having trouble with this. Let me go back up here. We're going to find all the factors of a number, and then we are going to write the largest that they both have in common. Now, there are other ways in order to do this, but this is the way that will keep us from being confused with a least common denominator, which is what I want to avoid. So for 18, we have 1 times 18, and then 2 times 9, and then 3 times 6. And you notice the way that I do this from a back and forth. And what I'm doing is I'm headed toward meeting myself in the middle, because I can go, okay, does 4 go into it? No. Does 5 go into it? And then the next number I see is 6. So I know I've met myself in the middle and I found all possible factors. So now I'll go to 36. So I'll do the same thing, 1 and 36. And then 2, does 2 go into it? Yes, 2 and 1, 2 and 18. And 3, yes, 3 goes into it, 3 and 12. And then next, 4, yes, 4 goes into it, 4 and 9. And then 5, no, 6, yes, and 6 times 6, so I've met myself in the middle. And now we're going to find the greatest one of these factors that these two numbers have in common. And so the greatest number that they have in common, it's better to kind of start from the top, right, since we are looking for a greatest one. And so we see 36, nothing up here. Oh, there we go, 18. So the greatest common factor between these two numbers is 18. And that would be true since how 18 is a factor of 36, or 36 is a multiple of 18, whichever way you want to look at that. So now we're going to do more than two numbers, but the process remains the same. So 12, I say, oh, well, 12 is 1 times 12, or it's 2 times 6, or it's 3 times 4. And you see I've met myself in the middle. And now I'll do the same thing for 10. So 10, we have 1 times 10, and then 2 times 5, and then 3, no, 4, no, so I've met myself in the middle, so I know I'm done. Finally, I have 24, so I say 1 and 24, and then I have 2, 2 and 12, and then 3 and 8, and then 4 and 6, and 5 doesn't go into it, so I've met myself in the middle and I know I'm finished. Now I'm going to start looking from the top. So 24, no. 12, yep, it's 12, but this one doesn't have 12, so that's a no-go. 8, no, no 8's there. 6's, oh, there's a 6 there, but no 6 here, so no go there. 4, 4 there, but no 4 here. 3, 3 there, but no 3 here. 2, 2, and 2. Ah, there it is. So we have 2's all the way around, so our GCF is 2. So now what we want to look at is how do we find the GCF of a variable term. And the GCF of a variable term is very simple. All we're looking for is the lowest exponent of a variable. So if we have this example here in part A, we have x squared, x to the fifth, and x to the first. So x squared, x fifth, and x to the first. Remember, if there's no exponent written, it is actually a 1. So this is our lowest exponent, and that makes our GCF between x squared, x to the fifth, and x to the first simply x. Now, if you ever want to check to see if you actually found the GCF, divide them. If they divide evenly, then you know you have a potential GCF. If there's nothing that can come out still further, then you absolutely know you have a GCF. We'll continue in the next lecture.